Bismillahirrahmanirrahim. We are discussing about effects of various factor on the speed of sound in an air in a air. Sound waves are compressional mechanical waves propagating in gas or air with a speed of v is equal to under root gamma p divided by rho. So the factor on which speed of sound depend: number one, density; second one, moisture; third one is pressure; fourth, temperature; and fifth one is wind. The first one is density. Density is the speed of sound is in a gas is inversely proportional to the square root of density, in which if we place gamma pressure constant, so V is inversely proportional to the square root of density. Like hydrogen, which is light gas, oxygen is denser. So the density of oxygen is greater than that of hydrogen. So in oxygen, the speed of sound will be smaller than as compared to hydrogen. So the second one is moisture. The presence of moisture in air reduces the resultant density of air. So by decreasing the density, so there will be increase in uh, speed of sound. So the speed of sound increases with humidity. Hence, the velocity of sound in damp air is greater than its value in dry air. So the third one is pressure. Pressure PV is equal to RT according to ideal gas equation. PV is equal to RT. So V is equal to RT divided by P. Rho is equal to mass divided by volume. When we put these value in this equation rho is equal to MPRT. In place of rho, when we put in this equation, so we get V is equal to under root gamma P over rho by placing the value of rho from this equation MP by RT. P with cancel with P, so we get under root gamma RT over M. From this equation, it is clear that speed of sound is independent of pressure, because from this formula, speed of sound depend upon uh, uh, constant, your universal gas constant, which is constant value, temperature, mass, but independent of pressure. So by increasing or decreasing in pressure of gas, there will be no change in the speed of sound in gas or air. Another thing, you can also explain with the help of this formula also. If you increase the pressure, so there will be increase in density. There will be decrease in volume and increase in density, so there will be no effect. This, if you increase in pressure, increase the pressure, there will be increase in density, so both will cancel with each other. So there will be no effect on the speed of sound in gas or air. And you can also explain with the help of this formula, which is given in your book. This is that in this case there is no involvement of pressure in this formula. So pressure, this is speed of sound is independent of pressure. So by increasing or decreasing the pressure, there will be no change in the speed of sound in gas. The fourth one is, these all are short question basically. In paper, you may ask that what is the effect of density on the speed of sound in a gas or air. So you will have to explain with the help of this formula. If the question came, what is the effect of moisture and the speed of sound in a gas or air. So you will have to also explain with the help of this formula the effect of moisture. The pressure you will have to explain with the help of these formulae the effect of pressure. So these are three short questions in this topic. There are four short questions basically. What is the effect of temperature on the speed of sound in a gas? So from this formula, it is clear that we have derived this formula in previously. So gamma is constant, R is constant, M is mass of gas is constant. So V is directly proportional to the square root of absolute temperature. Mean by increasing the temperature, there will be increase in the speed of sound in a gas or air. So speed, if the question came in your paper, like in previous paper, this was the question: why the speed of sound in is greater in hot air, hot air than in cold air. So for hot air, the temperature is high, so that's why the speed will be high, the speed will be greater. And for cold air, the temperature will be low, so the speed of sound in that air, cold air, will be low. So this is again another short question. Why the speed of sound in hot air is greater than in cold air, which depend upon this formula. You will have to explain with the help of this formula. And these questions, I telling you again, these questions are very important for examination point of view. And this topic overall is very important. I told you in the previous part one lecture, important topics and their short question. You have to learn it. If there is any confusion, you may ask from teacher. Another thing, this V is the velocity speed of sound at temperature T, and V naught is the velocity of sound speed of sound at 0 degrees centigrade. So at 0 degrees centigrade, the temperature will be T naught. So we divide both the value. V is equal to under root T divided by V naught is equal to under root T naught. So we get this formula. Now T naught is equal to 0 degrees centigrade plus 273, and T is equal to T degrees centigrade. T is any other temperature like 1 degree, 2 degree, 3 degree, 4 degree, and so on, plus 273 Kelvin. When we put these values in this equation, we get this one. Now square root is equal to 1 over 2. We again apply binomial theorem. Here binomial is missing. Binomial theorem. 1 plus power into this one, t plus t divided by 273, 1 plus nx, 1 plus nx. N is power, x is this term, t divided by 273. Now if we cross multiply this, we get V is equal to V naught plus V naught into T degree centigrade divided by 546. 2 multiplied by 273, 546. So V is equal to V naught plus, when we put the value, V naught is equal to 332 meter per second. So we get 332 divided by 546, 0, so we get 0.6 into T degree centigrade. The question arises in mind, if why we are not putting V naught is equal to 332 here. We can put here, but in numerical problem we are just deriving the formula. This you may ask also this formula, the effect of temperature on the speed of sound in gas, and derive this formula. V is equal to V naught plus 0.6 into T degree centigrade. So this formula is very important. This one, V is equal to V naught plus 0.60 degrees centigrade. So by changing the temperature, let's say there is 1 degree centigrade change in temperature. So there will be increase of 0.6 meter per second in the speed of sound. Clear? If we increase 2 degrees centigrade, so 0.6 multiplied by 2, we get 1.2 meter per second. We will have to add 332 plus 1.2 meter per second. So that will be the speed of sound according to that temperature. This formula is important for numerical problem also. So next is another thing is the last one is wind, effect of wind. When speed of sound is in the direction of wind, just as you are observing in daily life. So speed, if the speed of sound is in the direction of wind, so we write V plus V W. W is for wind. This is VW is the velocity, yeah, speed of wind, and V is the speed of sound. So there will the resultant will be enhanced, will be increased when the speed of sound is in the direction of is in the is in sorry this is in opposite direction, opposite opposite this one is opposite direction, is not is in the direction, is opposite to the wind speed. So we will have to subtract V minus VW. So if I summarize this, so the speed of sound, when the speed of sound is in the direction of wind, we write V plus VW. And when the speed of sound is in the opposite direction of wind, so we write V minus VW. You will have to solve example 8.3 and assignment 8.1 and example 8.4, which is given on page 264 and 265. You have to revise these topics, and if there is any confusion, inshallah, the teacher will discuss and you may ask from teachers. Thank you so much.